everyone, I am Adedo Jeremiah. I'm called Presidomator Jerry Springer. Today I'm going to lecture or do a tutorial on the concept of the first principle in calculus. I'm going to give you the definition of the first principle or how it is derived. And we are going to do a series of examples, or we are going to find the derivative of some functions, different kinds of functions from first principle. So the first thing is given that, or consider y to be a function of x. Let y be a function of s. I will add increment to both sides, that is, I will add increment to y plus delta y. I will also add increment to x. So that is the first thing. If you want to do first principle, add increment to both sides. Y plus delta y equal f of s plus delta s. Then I will subtract y. I will bring y to the other side. I will subtract y. Delta y will be equal to f of s plus delta s. Y will come here. It will become minus y. But from here, y is exactly f of s. Y is equal to f of s. So I will write f of s. So in dealing with first principle, the first thing is you will add increment. After that, subtract y from both sides. Then after that, the next thing is divide both sides by delta s. So delta y divided by delta s will be equal to f of s plus delta s minus f of s, everything divided by delta s. That's what we are going to obtain. So f of s plus delta s minus f of s all over delta s. So after that, the last thing we need to do is to take limits. To take limits as delta s goes to 0 of delta y over delta s. The same thing happens. So what you do to the left hand side, you do to the right hand side. You also take limits as delta s goes to 0 here of f of s plus delta s minus f of s divided by delta s. So limit as delta s goes to 0 of delta y over delta s will become all this one at my left hand side here will become dy ds is equal to limit as delta s goes to 0 of f of s plus delta s minus f of s all over delta s. All over delta s. So this is how we have come, or the derive the formula for derivative, for obtaining the derivative by first principle. So now we are going to do series of examples, like 10 examples on different kind of function. We will differentiate about 10 to 11 functions using first principle. So now, example. What examples? From first principle, obtain the derivative of the following. From first principle, obtain the derivative of the following with respect to s. So, number 1, y equal s squared. So we are going to obtain the derivative of this by first principle. So from what we are given here, number 1 is add increment to both sides. So we have y plus delta y is equal to, this one will become s plus delta s. So mind you, you don't write s squared plus delta s. If you write this is rubbish with confidence. This is not correct. So this is what we are going to have. So that at the end of the day, I have y plus delta y is equal to, expand this. By the time you expand this one will become s squared plus 2s delta s plus delta s all squared. That's what we are going to obtain. So after that, you subtract y. Take y to the other side, subtract y, so that you will be left with delta y, or make delta y the subject of formula. So delta y will be equal to s squared plus 2x delta s plus delta s all squared minus y. But y is s squared. Y is s squared, so that's minus s squared. So s squared, we cancel s squared, you'll be left with delta y to be equal to 2s delta s plus delta s all squared. So after that, after you've made delta y the subject of formula, divide both sides by delta s, divide both sides by delta s, or divide through by delta s. So when you divide through by delta s, I have delta y divided by delta s is equal to 2s delta s divided also by delta s plus this one will become delta s all squared divided by delta s. So this one will become delta y all over delta s is equal to, this one will become 2s plus delta s. After that, the last thing to do, of course, is to take limit as delta s goes to 0 on both sides. So you take limit as delta s goes to 0 of both sides. So at the same time as well, limit as delta s goes to 0 of 2s plus delta s. What is here will become dy ds. So this one will become dy ds is equal to 2x. Anyway, you see delta s here, put 0. 2s plus 0, which is equal to 2s. So that means if you differentiate s squared, the answer is 2s. So this is the proof, or this is how to obtain it by first principle. Example 2. Y equal 1 over s. Y is equal to 1 over s. We want to differentiate this from first principle. So now, again, as you can see, the first thing to do is you will add increment y plus delta y is equal to 1 over s plus delta s. Please mind you, observe where how I'm writing my increment. Don't write 1 over s plus delta s. This is not correct. This is not correct at all. So after that, bring y to the other side so that I will have delta y to be equal to 1 over s plus delta s minus y. But y is what? 1 over s. So y is 1 over s. Here I'll find the LCM. Delta y, I'll find the LCM here is equal to, the LCM here will be s open bracket s plus delta s. All these ones divided by s plus delta s will be left with s. S times 1, s. Minus all this one divided by this, s will cancel s, will be left with s plus delta s. S plus delta s times 1, s plus delta s. So that is what I'm going to obtain. So if you open the bracket here, this one will become s minus delta s. S minus s will cancel out, you will be left with minus delta s. So that I have delta y will be equal to minus delta s all over s open bracket s plus delta s. So that means I'll be left with minus delta s all over s open bracket s plus delta s. That's what I'm going to have. That's what I'm going to obtain. So the next thing is divide both sides by delta s. So the next thing is to divide both sides by delta s. Now to divide both sides by delta s, I will have delta y divided by delta s is equal to minus delta s all over s open bracket s plus delta s multiplied by 1 over delta s. That's what I'm going to have. So I will have delta y over delta s to be equal to delta s. We cancel delta s, so I'll be left with minus 1 all over s open bracket s plus delta s. So the last thing to do now is to take limits. You take limit as delta s tends to 0 on both sides. So limit as delta s goes to 0 on both sides of delta y over delta s. Limit as delta s goes to 0 of minus 1 over s plus delta s. All this one will become dy ds. Anywhere you see delta s here, put 0. So this one will become minus 1 over s open bracket s plus 0. S plus 0 is here, so that's minus 1 over s squared. So the y ds is minus 1 over s squared. If you differentiate that, we want to move to the third example. So for the third example, see, I have y to be equal to root s. We want to differentiate with respect to s here, y equals square root of root s. So this is what we are going to have. Add increment to both sides. I have y plus delta y to be equal to square root of s plus delta s. So this is what we have. Y plus delta y equals square root of s plus delta s. Bring y to the other side. Delta y will be equal to square root of s plus delta s minus root s. So what do we do from there? So from here, God told me that we should rationalize the numerator. You know, all this one is over 1, you know, sod. Rationalize the numerator by taking the conjugate. So before God and man, I also rationalize square root of s plus delta s minus root s all over 1 multiplied by square root of s plus delta s plus root s. Everything over square root of s plus delta s plus root s. So when I hang here, God told me that I should take the rationalization of the numerator, or take the conjugate of the numerator and rationalize the numerator, so that I will obtain this. So by difference of 2 square at the numerator, I will be left with delta y. At the numerator, I will have difference of 2 square. That means I will have square root of s plus delta s all square minus square root of s all square. Difference of 2 square means that when you have the bracket a minus b multiplying a plus b, the answer is a square minus b square. So this is like a minus b multiplied by a plus b. So the answer will now be a square minus b square. The denominator will remain the same. Square root of s plus s delta s plus root s. So I will have delta y is equal to square, we cancel square root, so I'll be left with s plus delta s at the numerator minus square, we also cancel square root, minus s all over square root of s plus delta s plus root s. So that we have I can have delta y to be equal to s minus s will just be equal to delta s. It will just be equal to delta s all over square root of s plus delta s plus root s. That's what I'm going to have. So at the end of the day, I will divide both sides by delta s. So, after I've made delta y the square root of formula, I will divide both sides by delta s. So, divide both sides by delta s, I have delta y divided by delta s to be equal to delta s all over square root of s plus delta s plus root s multiplied by 1 over delta s. 1 over delta s, or delta s, we cancel delta s, so I'll be left with delta y over delta s is equal to 1 over square root of s plus delta s plus root s. S plus delta s plus root s. So after that, the last thing to do is that we will need to take the limits. Take the limit of both sides. Limit as delta s goes to 0 of delta y over delta s. The same thing, limit as delta s goes to 0 of what is here? 1 over root s plus delta s plus root s. So that is what we are going to have, 1 over root s plus delta s plus root s. So all this one will become the y ds. The y ds is equal to 1 over, so in this case as well, anywhere you see delta s, put 0. S plus 0 is just root s plus root s. So that I will be having 1, or I'll be left with 1 over 2 root s. So the answer to this is 1 over 2 root s, and that is the derivative from first principle. So now the fourth example. So for the fourth example, for the fourth one, the fourth example is d y is equal to 1 over root s. So again, thank God for the previous example. This way, we will just apply what we have done in the previous example. So add increment to both sides. So y plus delta y equal 1 over square root of s plus delta s. Bring y to the other side. Bring y to the other side. I have delta y to be equal to 1 over square root of s plus delta s minus y. But y is equal to 1 over root x. 1 over root x. So the next thing to do here is we actually need to look for the LCM. We need to obtain the LCM in this case. So I have delta y to be equal to the LCM here will be exactly square root of s plus delta s. Since they both have square roots, so we can easily multiply what is inside the bracket, what is under the square roots together. So this one divided by this will be exactly root s. So this one will be root s minus this divided by this will be exactly this. So minus square root of s plus delta s. Again, we will need to rationalize by taking the conjugate of the numerator as well. So we need to rationalize by taking the conjugate of the numerator. So I will have delta y to be equal to square root of x minus square root of s plus delta s all over square root of s open bracket s plus delta s. So I multiply now by the conjugate, multiply by square root of s plus, I multiply by the conjugate, multiply by square root of s plus square root of s plus delta s all over the same thing as well, square root of s plus square root of s plus delta s. Just the way we deal with sod. So that's how we are going to deal with this one as well. So I will have So this one will be delta y all over delta s. Oh no, before I do that, let me see what I'm going to obtain. This is the difference of two squares as well. A minus b multiplied by a plus b. That will be a square, square root of s all square, minus b square, square root of s plus delta s all square, everything over what we have as the denominator, square root of x, s plus delta s, open another bracket, I have root s plus root s plus delta s. So that this one will now be delta y is equal to s, because square will cancel square root. The same thing happens here, square will cancel square root as well. This one will also be s plus delta s. Everything over square root of s plus delta s. Then I have square root of x plus square root of s plus delta s. That is what I'm going to have. So I have delta y. I have delta y to be equal to s minus s. This is minus s minus delta s. S minus s should be 0. I'll be left with minus delta s all over square root of s plus delta s, open bracket, square root of s plus square root of s plus delta s. So lastly, before we do the last thing, divide both sides by delta s now. So after I make delta y the solvent, divide both sides by delta s, I will have delta y divided by delta s to be equal to minus delta s all over square root of s plus delta s, open bracket, square root of s plus square root of s plus delta s plus delta s multiplied by 1 over delta s, multiplied by 1 over delta s. So delta s will cancel delta s. So at the end of the day, this is what I'm going to have at the end of the day. At the end of the day, I will have delta y to be equal to minus 1 over square root of x, open bracket, s plus delta s. Then another bracket, square root of x plus square root of s plus delta s. That's what we are going to obtain. So after that, the last thing to do is to take limit of both sides. Take limit as delta s tends to 0. We take limit as delta s tends to 0, so limit as delta s goes to 0 of delta y over delta s is equal to limit as delta s goes to 0 of minus 1 over square root of s, open bracket, s plus delta s, open bracket, square root of s plus square root of s plus delta s. That's what we are going to have. All these ones will become the y ds. For this case, anywhere you see delta s, put 0. So this one will now be minus 1 over, this one will give me square root of s. S plus 0 will be s. S times s will give me s squared. So this one will be square root of s squared, open bracket, this one will be square root of s plus this one as well. S plus 0 will be square root of s. That's what I'm going to have, so that at the end of the day, this one will now be minus 1 over square root of s squared will be s, square will cancel square root, multiplied by 2 root s, because root s plus root s is 2 root s. So at the end of the day, I have minus 1 over 2 root s. That is the answer. The answer is minus 1 over 2 root s. That is the answer for this one. So if you are given any question that has maybe square root of s, cube root by first principle, this is the method or the approach you are going to be using. As well, if you are given fourth root, this is how you approach. This is how you are going to solve it. Just follow the same procedure. You are going to obtain an answer. So the fifth one, E, is y equals sine s. Y equals sine s. We want to differentiate this from first principle. Y equals sine s. That is the next thing we want to do now. But of course, the normal procedure, add increment to both sides, y plus delta y equals sine s plus delta s. As you can see, bring y to the other side, then delta y will be equal to sine s plus delta s minus y, but y is sine s. Y is sine s. So from here I don't know what to do again. Then God told me that I should recall from the product formulae that when you have sine A minus sine B, what does that give me? So I followed God, and God said, what is sine A minus sine B? Recall from trigonometry. Then I recall that sine A minus sine B from trigonometry is 2 cos A plus B over 2 sine A minus B over 2. This is exactly from product formula in trigonometry. So this is gotten from trigonometry. That's what I'm going to use here. God said I should use it. That I should let A be s plus delta s and B be s. So delta y will now be, instead of having, so this is like sine A minus sine B. So sine A minus sine B is 2 cos A plus B over 2 sine A minus B over 2. So all this one will now be 2 cos A. A is s plus delta s plus B. B is s over 2 sine A minus B. A is s plus delta s minus B. B is s over 2 as well. So that I will have delta y to be equal to 2 cos s plus s will give me 2s. 2s plus delta s over 2 sine delta s over 2, because s minus s will give me 0, delta s over 2. So that is what I obtain now. That is what I have. So the secret behind this, to solve this by first principle, is to know this. Is to know this trigonometry identity. That's what I have applied here. So after that, the next thing is to divide both sides by delta s. Divide both sides by delta s. So I have delta y divided by delta s. So this one will now be equal to 2 cos 2s plus delta s over 2 sine delta s over 2. Everything divided by delta s. That is what I'm going to obtain. That is what I'm going to have. So the next thing to do now is that delta y 2 cos 2s plus delta s over 2 sine delta s over 2. And now restrict, instead of having all over delta s, and now put that delta s only on sine. Only on sine. Now, the reason is because the reason is very simple. Now, note that limit as s goes to 0 of sine s over s is 1. This is from the standard limit. Limit of sine s over s is 1. So, because very soon after this, the next thing to do is to take limit as delta s goes to 0. So, since I have sine s over s, once what is here, limit as s goes to 0 of sine s, if what is here is what is at the denominator as well, the answer will be 1. So, what is here is delta s over 2, but I have delta s here, so I have to put over 2 here as well. So, what do I do? This is what I'm going to do. Multiply both numerator by 1 over 2 as well as the denominator by 1 over 2. So, by the time I do that, I'm going to have delta y over delta s to be equal to, so this is what will happen. The one I multiply at the numerator, these two, will cancel the 2 here. It will cancel the 2 there, so that I will be left with cos 2s plus delta s all over 2 sine delta s over 2, everything over delta s times 1 over 2 will just be exactly delta s over 2. So now I can take limits. So limit as delta s goes to 0 of delta y over delta s is equal to limit as delta s goes to 0 of cos 2s plus delta s over 2 sine delta s over 2, everything over delta s over 2. So, at the end of the day, we will have limit as delta s close to 0. Anywhere you see, for cos, anywhere you see s, delta s put 0. So that I will be left with cos 2s plus 0 over 2. 2s plus 0 is 2s, that's 2s over 2. Then multiply by, don't forget, from this sine s over s, limit at s goes to 0 of sine s over s gives 1. So that means what is here and if what is in front of sine and what the argument of sine and what is at the denominator are the same, the answer is 1. That is from the standard limit. So the same thing happens here. Since I have delta s over 2 here, so once I have delta s over 2 at the denominator as well, and it is going to 0, delta s over 2 will go to 0 like that. So this one will also be 1. That is from standard limit. 2 will cancel 2 cancel 2, I will be left with s. Cos s times 1, the answer will be cos s. So limit as delta s goes to 0, as delta s goes to 0 of delta y over delta s, that will give me the y ds. So that means the y ds is equal to cos s. So that is cos s. That